we present the AutoEDU Wheel Alignment Educational Trainer, designed for professional training in wheel geometry and suspension alignment. Developed with the support of wheel alignment specialists, this stand provides comprehensive hands-on practice in adjusting camber, caster, toe, and steering axis inclination angles on both front and rear suspensions. The trainer features a McPherson-type front suspension and a multi-link rear suspension.
All components are fully visible and accessible, allowing students to clearly understand and perform real-world alignment procedures.
Thanks to its mobile, foldable, and compact construction, the stand is well suited for classrooms of any size. Preparing the trainer for work is quick and simple. Unlock the main connectors, unfold the stand into its working position, and secure it with locking pins. This design ensures convenient storage, easy transportation, and flexibility for a variety of training environments. This training stand is designed for convenient repeated use. It is lightweight, mobile, safe, and highly detailed. Before starting wheel alignment adjustments, the wheels must be secured. The front wheels are equipped with an integrated hydraulic handbrake, while the rear wheels are locked mechanically. For frequent operation, our engineers recommend applying lubrication fluid to the adjustment points occasionally, ensuring smoother and easier regulation. The stand is equipped with OEM standard R14 wheels, making it compatible with virtually all types of wheel alignment measurement tools. Before demonstrating the full adjustment possibilities, let us briefly review the main components of the training stand. Front shock absorber position adjustment, toe adjustment from the shock absorber, camber adjustment from multiple fork mounting points. Front frame position adjustment, toe adjustment using the steering tie rod, steering tie rod angle adjustment, front fork height adjustment. Rear suspension adjustments, rear wheel toe adjustment via control arm, camber and toe adjustment from the rear arm, camber and toe adjustment using shims. Additional features: steering wheel position locking, mechanical locking of the rear wheels, hydraulic handbrake for the front wheels. Next, we present the adjustment possibilities with this trainer, beginning with the rear axle wheel alignment. Several points allow students to adjust toe by lengthening or shortening the rear control arm. By doing so, they can observe how changes in arm length also influence other geometry parameters, such as camber angle, due to shifts in suspension plane alignment. Rear wheel camber adjustment is carried out by modifying the eccentric mounting of the wheel arm. By rotating the eccentric bolt, the angle of the wheel relative to the vertical axis changes. This alters the distance between the upper edge of the wheel and the vehicle body, directly influencing the camber angle. Negative camber, where the wheel tilts inward at the top, improves cornering stability and grip, while positive camber, where the wheel tilts outward, may reduce stability and cause uneven tire wear. With this trainer, students can clearly see how even small adjustments of the eccentric mount affect wheel positioning and suspension geometry. This trainer also allows camber adjustment at the suspension points by loosening the bolts and moving the upper suspension fork inward or outward.
Pamatyti, kaip juda ta vieta. Rašystai. Va. O šitaip gal tiesiog.
Another method of adjusting camber and toe is by using shims. While this technique is less common in modern vehicles, it was widely applied in older passenger cars. This educational trainer provides students with the opportunity to understand and practice camber adjustment using additional shims. To perform this procedure, the three main bolts on the wheel hub must first be loosened. Shims of the required thickness are then inserted between the beam plate and the wheel hub. For positive camber adjustment, shims are placed at the upper mounting point. For negative camber adjustment, they are placed at the two lower mounting points. Toe adjustment is achieved by inserting shims on either the left or right side, depending on the required correction.
Now let us move on to the front wheels. This trainer provides multiple adjustment options, allowing students to practice setting toe, camber, and caster on a McPherson-type suspension.
Front wheel camber can be adjusted at 4 different points. One method is by using eccentric bolts at the frame and fork mounting. By turning the bolt with a wrench, the position of the wheel relative to the frame changes, which alters the camber angle and the distance between the upper wheel edge and the body. In addition, the fork eccentric adjustment allows caster angle regulation. The rear vertical mounting point of the fork, equipped with an eccentric bolt, changes the forward or backward tilt of the steering axis. This directly affects steering stability, self-centering of the wheels, and overall handling response. Another adjustment point for camber demonstration is at the shock absorber bolts near the wheel hub. By loosening these bolts, the position of the strut relative to the hub can be shifted, which changes the wheel's vertical tilt. This adjustment directly modifies the camber angle. When the strut is moved inward, negative camber increases, improving cornering grip, but also causing higher inner tire wear. Moving the strut outward reduces negative camber or creates positive camber, which may ease steering effort but can reduce stability. By adjusting the shock absorber position at the upper mounting point on the front frame, it is possible to change both camber and toe. Once the locking bolts are loosened, the entire strut assembly with the hub and wheel can be shifted vertically or horizontally. This movement allows precise adjustment of wheel tilt, as well as its alignment angle. Front axle toe adjustment, which is regulated by changing the length of the steering tie rod. Another additional adjustment on the front axle is steering angle regulation. By loosening the indicated bolts on the wheel hub and repositioning the spacers between the steering tie rod bracket and the hub, we can change the distance of the tie rod end. This directly influences the degree of wheel turning, allowing us to increase or decrease the steering angle. To maximize the educational value, this trainer also allows adjustment of the steering tie rod position. Changing this position alters the suspension geometry and the wheel turning angle. This adjustment directly affects how much the wheel rotates when the steering wheel is turned, for example, through a full 360 degrees. By reducing the steering arm length, students can clearly see how the wheel turning angle increases or decreases depending on the new tie rod position. The front axle can also be adjusted in relation to the main vehicle frame by loosening the mounting bolts of the front suspension frame. This frame can be shifted in all directions, simulating chassis designs where wheel alignment is regulated through the entire front subframe.
visaip kaitalioti jo padėtį. Tiek pirmin, tiek atgal.
After completing the training session, the stand can be quickly and easily folded for convenient transport and storage. Its design allows it to be stored vertically, requiring minimal space compared to other wheel alignment training alternatives, such as using a full vehicle.
The AutoEDU Wheel Alignment Educational Trainer offers a wide range of adjustment possibilities, covering all key parameters of wheel geometry.
Unlike using a full vehicle, this stand provides clear visibility of every component, easy access to all adjustment points, and quick resetting between lessons. Its compact, foldable design saves valuable classroom space while still offering realistic hands-on experience with OEM parts. With the ability to simulate different alignment methods found across various vehicle types, this trainer is a versatile and efficient solution for mastering wheel alignment in any scenario.